Hello, this is a video tutorial on the Big Ideas Geometry textbook for the 2.1 section Conditional Statements. So the learning objectives for this section are that you can write conditional statements, you can use definitions written as conditional statements, and you can write biconditional statements. All right, so the major core concept in Chapter 2 of Geometry dealing with logic and conditional statements is a conditional statement. So it's a logical statement that has two parts. One is called the hypothesis, which you'll usually see labeled as the letter P, and the second part is the conclusion, usually labeled as the letter L. Whenever a conditional statement is written in the if-then form, anything that follows after the words if contains the hypothesis, and anything after the words then contains the conclusion. So if you see it written in words if P then Q, where P is your hypothesis, then Q is your conclusion. You can also see it as symbols of P with an arrow drawn towards Q, and that reads as P implies Q. If P, then Q. Okay, so just being able to identify within these statements what the hypothesis and what the conclusion are, and then rewriting the conditional as an if-then statement. So we're going to use multiple colors on this video. Red is going to be used for the hypothesis, blue is going to be used for the conclusion. So our first statement is all birds have feathers. So the way that you write this as a conditional statement is including the words if and then. So if an animal is a bird, then it has feathers. It's written in red as the hypothesis or your P. Blue is your conclusion or your Q. Going into the second example. You are in Texas if you are in Houston. Again, we're going to rewrite this as a conditional statement in the if-then form. So if you are in Houston, then you are in Texas. Notice how there's already an if in this statement. So the hypothesis is already there for us. We've moved that first and kind of switched the order is something that we're going to be doing a little bit more later. But anything after the word if in your conditional statements is your hypothesis. In this example, it's already here. Okay, another core concept is negation. The concept of negation of a statement is doing the opposite of the original statement. So to write the negation of your hypothesis or your statement P, you write the symbol for negation, which is the squiggly line before the letter. So the words not P or not followed by your hypothesis is just the symbol with a squiggly P. On your keyboard, it's probably going to be in the upper left-hand corner if you're ever going to need to type that. Okay, so rewriting some of these conditional statements as the negation. So to say the ball is red, in order for you to negate that, usually it's going to be as simple as inserting the word not. So you would just say the ball is not red. Same thing if the word not is already in there. You could think about negating by adding the word not, and any double negative becomes a positive. Or you can just think, right now it has a not, so I'm going to take the not out. So instead of saying the cat is not black, we would say the cat is black. So negation is just taking the opposite sign or making something not what it originally was. Okay. So this is getting into the section of switching things around and negating and creating different types of conditional statements. So for the purpose of this section, assume that every single conditional statement is if P then Q. So it's always going to start in alphabetical order. If your hypothesis, then your conclusion. So in order to take your conditional statement and create a converse, you are going to swap your hypothesis and conclusion. So just take the order and switch which one comes first. So instead of saying if P then Q, it would read if Q then P. So any words that would be after your if go to your conclusion, and any words that are after your then would go into your hypothesis. To find the inverse, you would keep the same order as your conditional statement, but you would negate or put the words not or take out the words not if they were in there of both your hypothesis and conclusion. So it would read if not P, then not Q. Okay, both. You have to do both for the inverse. Then the contrapositive is the hybrid or the combination of both your converse and inverse. So you're going to first write the converse. So first thing you're going to do, starting with if P then Q, you're going to swap the order so it becomes the converse, if Q then P. Then you are going to negate it after it is swapped. So it would read if not Q, then not P. And the symbols for all of those are on the right. Again, using the arrows with the P and Q and the negation symbols in front where it applies. So this example we're going to walk through assuming that P is the phrase you are a guitar player and Q is the phrase you are a musician. We are going to write each statement of those P then Q's using our new words, then determining whether it is true or false. So first we're going to write the original conditional statement if P then Q, but we're going to replace P with you are a guitar player and Q as you are a musician. So conditional statement, if P then Q, plug in your P and plug in your Q. If you are a guitar player, then you are a musician. Okay, so that's writing just the if P then Q conditional statement. Now we need to determine whether it is true or false. This one is true. If you are able to play the guitar, you are creating music and you would be considered a musician. All guitar players are musicians. Now the converse, we are going to take our original conditional statement where we have our if P then Q, and we are just going to take the words that are after if and after then and swap where they are. So it's still going to say if first and then, but the word phrases that come after if are now going to come after then. So instead of if you are a guitar player, then you are a musician, it is going to read if you are a musician, then you are a guitar player. So the musician part is now coming first. The guitar player part is coming second. Still reading if, then. So now we need to determine, is this true or false? If you are a musician, then you are a guitar player. No, this is not true. It's false. It is possible in a world where you are a musician that plays many of the other instruments and cannot play the guitar. There are other ways that you can create music without being a guitar player. Part C, the inverse. Again, we're going to go back to our original conditional statement, if P then Q, and the inverse says to negate the hypothesis and the conclusion. So the order is going to be the same, but now we're going to include the words not. So let's go ahead and write our if not P, then not Q, but replace P and Q with you are a guitar player and you are a musician. So it should now read, if you are not a guitar player, then you are not a musician. Again, this is false because even if you do not play the guitar, you can still be a musician. So just because you are not a guitar player does not automatically mean that you are not a musician. Again, you can play other instruments without being a guitar player. The last part, D, contrapositive, is going to be the combination of both the converse and the inverse. So you're going to take your converse statement, since we already have that done, it's already swapped, and then we are going to negate each part. So it should read if not Q, then not P. We're going to plug in our Q and our P in that spot, and it should read if you are not a musician, then you are not a guitar player. This statement is true because if you are not a musician, then you cannot play any musical instrument, the guitar included. No person who is not a musician cannot also be a guitar player. So that is the true-false table statement of this conditional, converse, inverse, and contrapositive. So now, looking at some definitions that may have briefly been introduced in some other classes and being able to determine if each one of the definitions are good definitions. Now, what's going to be considered a good definition, we'll go over a little bit later, but let's just look at these statements in relation to the diagram. So the diagram we have has 8 points A, B, C, and D, where lines A, C, and B, D are intersected at the point E, and it looks like one of those is a right angle. So part A, the statement reads, line AC is perpendicular to line BD. That's what that upside down T is, as it forms perpendicular lines. Well, we do know that line AC is the horizontal line going through line BD, again, intersecting at the point E. And notice that right angle is being formed between the two lines. Well, we know based on the definition of perpendicular lines that they form a 90-degree angle, that this statement is true. So since the right angle symbol in the diagram tells you that, it's going to form a right angle. Now, part B, angle AEB and CEB are a linear pair. Well, AEB is created in that upper left-hand quadrant, and angle BEC, or CEB, depending on the order, is in the upper right-hand quadrant. Yes, this statement is true, and we'll take a look a little closer in the diagram why. By definition, if the non-common sides of an adjacent angles are opposite rays, then the angles are linear pairs. We are able to draw a straight line from A to C going through the vertex E, since those are our non-common sides. Now part C, EA and EB are opposite rays. EA is that ray in the purple where it's starting in the middle and moving to the left. EB, again, is that purple ray where it's starting in the middle and going up. Thinking back to our definition of opposite rays, hopefully you're able to say that no, this is not a true statement. They are not opposite rays, because the definition has to be that the point lies on the same line of both of the rays, and they are not. You are changing the direction in which the ray is going, and it is not on a straight line to get from point A to point B. Okay, biconditional statements. So they're very similar to conditional statements because it has the phrase conditional in them. But this is a statement that contains the phrase if and only if. So you're never going to have an if and a then in a biconditional statement. Your if and only if is going to be smack dab in the middle between your hypothesis and conclusion. So instead of reading if P then Q, it reads as P if and only if Q. And in biconditional statements, your symbols are going to have arrows in both directions. It is not one implies the other. It is P implies Q and Q implies P at the same time. So any definition that can be written as a biconditional statement would be considered a good definition. So we're going to read some biconditional statements in this one. So the definition that we are given is that if two lines intersect to form a right angle, then they are perpendicular lines. So this again is referencing back to the example we did on the last slide, where you had two lines intersecting to form a right angle to figure out if they are perpendicular. So this right here is a conditional statement. It is an if, it is a then, it has a hypothesis, and it has a conclusion. So we're going to label those accordingly. We're going to let P be the hypothesis, two lines intersect to form a right angle. Then we're going to let the Q be the phrase after then. They are perpendicular lines. We're going to use colors to help identify those. And then we're going to write that definition of if P then Q. So if two lines intersect to form a right angle, the red is the hypothesis, then they are perpendicular lines. Blue is your conclusion. Then you're going to write the converse of this conditional statement. So that means you're going to take your red and your blue and swap them, or your Q and your P, if you are able to associate those with the letters. So if two lines are perpendicular lines, then they intersect to form a right angle. Using that definition and its converse to write the biconditional statement, you're going to take that new converse statement and put in the words if and only if. So instead of if and then, you're going to say that two lines intersect to form a right angle if and only if they are perpendicular lines, because both your conditional statement and your converse are true at the same time. That guitar player and that musician example, you cannot write a true biconditional statement because the converse is also not true. Both your conditional and your converse must be true to write a biconditional statement. And if you can do that, then it's going to be considered a good definition. And that is the end of the video.